Okay, so what I want to do today is to help you guys practice, to help you not only with lab number 4, so I think it's part number 2 for lab number 4, but also because I need you guys to be able to do this for um your final assessment. Here, let's just assume, or let's imagine we have some information. So let's say we have some information. Like for example, you're at a site, you took water levels, right? So you took water levels, and you know that the elevation, the ground surface elevation is, let's say, 210.00 meters above sea level. And then you took a measurement of the ground level in the aquifer. So you took this measurement in the well with the instrument that we've discussed. And let's say this is 3.51 meters below ground surface. So then what you do is you use this information to calculate the groundwater elevation. What does that calculate as? So it'll be the ground surface elevation, 210.00 minus 3.51 meters. And this will give us, what will this give us? So 210 minus 3, that's 207 minus 5.51, 206.49 meters below or above mean sea level. That is how you calculate that. Now, what you can then do is in your software or on the computer, what you then do is you plot this. So you plot this. So let's imagine that we have, let's say that's borehole 1, and we've got 206.49. Let's say you've got another borehole here, and that's 205.11. So these are all the elevations in meters above sea level, right? Even though you see wells at the ground surface, but let's say this is 207.66, and this is 206.44. So the computer, what it's going to do, it's going to contour, right? So let's say the first contour that goes through here is 207, 207 meters above sea level. Then you've got the next contour. So it's going through here, 206 meters above sea level. And then maybe your computer is going to estimate the next contour going through here. It's 205. This is 205.5, 206.5, 207.5, right? And you also have a scale here. Let's say this is 10 meters. So you can actually use this information, number one, to create a flow net. So I'm going to draw that. Maybe I'll draw that with 3. You just draw a line perpendicular to the contours. Meaning it makes a 90-degree angle. That is your flow net. Oh, this is going to be in this direction. Sorry. It'll be in this direction. And and you'd have something looking sort of like this. That's your flow net. And let's say if this was north, this is north, your groundwater flow would then be easterly, or sorry, westerly. Westerly. Not exactly west, but westerly. Now, another thing that you can do is now you can determine, number one, you've got the flow direction. Now you can also determine, can you determine the hydraulic gradient? Hydraulic gradient. How do you do that? You got this information. How do you determine hydraulic gradient? Pick 2 points. You can even use contours. So I'll say point A. I don't like this color. It's not going to be helpful. I'll use red. Point A and point B. Now, I know between point A and B, DH is going to be, so this is point B is 205.5, and this is 207.5. So it's 207.5 minus 205.5, which is equal to 2. Now what I need to do is I need to determine the distance between these two. And you can take a ruler and say, okay, so 2.2 inches is 10 meters, or in this case, we'll use centimeters. So 6 centimeters is 10 meters, according to the scale. And the distance here is 16. So you convert that. 6 centimeters is equal to 10 meters. So 16 centimeters is equal to 10 over 6 times 16, which will give you, so let me go ahead and run that here on a calculator. 10 by 6 times 16. That's 27 or 26. So DL is 26.7. So I am now basically able to calculate, and I'm going to erase some of this in this corner here just to make it easy. So DH by DL, what is that going to be equal to? 2 divided by 26.7, which calculates to 2 divided by 26.7 equal to 0.0749 meters per meter. That is your hydraulic gradient. And if you were able to plug in K, you can then determine the velocity. Okay, and this is going to be helpful to you. Now, the reason why I bring this up, and I think it's important for you to understand this, is that this week we don't really have a lab per se, and I've got our lecture recording. So use this time, this extra time that you have, to practice determining hydraulic gradient. So I've got two sites here. I'm going to share with you the first one. So what you can do here is determine, so there will be different hydraulic gradients, 3 in this case. They'll have a different hydraulic gradient over here. Now I'm gonna, well, let's see if it works. So this area down here. Down here. Actually, I don't really need it for this exercise. You could actually say that you've got 3 different hydraulic gradients. One in this area, one which is relatively flat in this area, and one in this area. And what a lot of people do is they'll take an average of, let's say over here, here, so they'll calculate three different ones. Or they'll calculate 4 or 5 different ones. So the method to calculate the hydraulic gradient here would be to determine, let's say we're just looking at this area here. So maybe you want to use 2 points, one here and another here. And then what you need to do is you need to determine the distance between these 2 points. What's the distance? How do you determine the distance? Well, you know the elevation, right? Based on the contour. So that's 1196, that's 1193. The difference is what I'm going to use for DH in meters. And you've got, there should be a scale somewhere here. There's a scale. Using this scale, you can estimate what this distance is at two different locations. You fall same that I had out, right? And do the same for the other one. In this case, for example, where would I be more concerned? In this case, where would I be more concerned? Down here. Down. So I would say the representative gradient across the site is more like this. This would be right next to the river. This is not representative. This would be the representative gradient. And maybe to use different points like here to here, here to here. And that will set you up nicely for the lab and your final assessment. Okay. All right. Any questions? Just let me know when we meet next.